Have you ever wondered if our entire universe is actually a simulation? What if everything you see, the stars, the earth, even yourself, is part of a giant cosmic program? Today, we will explore one of the most fascinating questions in science. Is reality real, or are we living inside a simulation?
Imagine for a moment that everything you see is not real in the usual sense. Imagine your world. This reality is like a scene in a very advanced video game. The trees outside your window, the distant shimmering stars, even your own thoughts and feelings. All of it could be just lines of code. This intricate program runs on a computer of unimaginable power. This idea sounds strange. It certainly sounds like a plot from a science fiction movie. But some very serious thinkers, they call it the simulation theory. So, what exactly is the simulation theory? Let's break it down into a simple visual idea. The theory proposes that our universe is not the base reality. Instead, it is a computer-generated world. A civilization far more technologically advanced than our own could have created this simulation. Think of a computer screen filled with millions of tiny dots of light. These dots are called pixels. Now imagine scaling this idea up. The smallest particles might be like those pixels. The laws of physics would be the algorithms that dictate how these bits interact. From simple dots to worlds that can trick our senses, built on exponential computing power. If countless simulations are created, then statistically it may be more likely we are in one than in the single base reality. The modern discussion was shaped by an Oxford philosopher named Nick Bostrom. In 2003, he wrote a landmark paper posing a logical challenge. Instead of proof, he offered Bostrom's trilemma. One of three propositions must be true. First, civilizations almost always go extinct before reaching a post-human stage. Post-human power could run high-fidelity ancestor simulations. Second, they survive but lose interest in running ancestor simulations. Third, if they do run them, we are almost certainly living in a simulation. If billions of simulated worlds exist, simulated minds would vastly outnumber biological ones. If extinction and disinterest are false, the simulation option dominates. It is a stark, probabilistic lens, not a detection. Why do some technologists and physicists take this seriously? The universe speaks mathematics, from orbits to subatomic interactions governed by precise laws. It resembles a physics engine, consistent rules everywhere. John Archibald Wheeler, it from bit, reality from information. If the universe is informational, it could be computed. We already simulate weather, diseases, galaxies, molecules. As realism grows, it's hard to exclude that others did it before us. If it's possible in principle, we must consider we are its product. Compelling hints, not proof, yet enough to keep the question alive. A universal speed limit. Nothing outruns light in vacuum. In a simulation, a speed cap could mirror processor update rates. Like a game's refresh rate, an analogy, not an explanation. At the Planck scale, our theories falter, space and time blur. Some speculate a fundamental resolution, universe as pixels. If space were a lattice, ultra-energetic particles might deviate. Researchers seek tiny anomalies in paths and energies. So far, no definitive proof. The search continues. A discrete universe would be a monumental shift. Supportive, not conclusive. Provocative clues, still short of certainty. Quantum mechanics, where reality gets weird. Unobserved, particles act like waves, even one at a time. Measurement forces a definite outcome. Like games, details render on demand, a resource-saving analogy. Entanglement links outcomes across distance, no signal faster than light. In a simulation, linked data updates together, built into the code. Not proof, yet an intuitive way to picture the oddities. If there are glitches, they blend back into seamless rules. Observation changes what we can say. Less magic, more method. Quantum strangeness invites metaphor, demands rigor. Servers in the sky, let's picture the machine, not a desktop. Think planetary, even stellar scales. a vast structure capturing stellar energy to compute worlds. Racks upon racks, cold, hyper-efficient, purpose-built. Those lights mark the flow of data, the very substrate of our reality. Simulators might be post-biological, mines of pure information. To them, launching a universe could be like starting a program. We feel continuity. The computer steps through discrete states. The past is stored data, the future not yet computed. We move frame to frame, oblivious to the engine beneath our world. The vast majority of scientists remain skeptical. A scientific theory must be falsifiable. Simulation theory offers few clear, testable predictions. Glitches, either new physics or a well-made simulation. Too flexible to test. Common sense says the world feels undeniably real. The argument assumes godlike computing, interest in ancestors, and simulating consciousness. Fundamental limits may make full-fidelity universe simulation impractical. Without falsifiability, the idea leans philosophical, not hard science. Skepticism keeps us honest, demanding evidence. Compelling? Yes. Conclusive? Not yet. If we're simulated, what simulates the simulators? Turtles all the way down. Where does the chain stop? What is base reality? Free will. Are we pre-programmed, or do choices still matter? If creators exist, what duties do they owe beings who can suffer? Is it ethical to run worlds with disease and injustice, just for study? Others argue, simulated or not, pain, love, and consciousness are real to us. Our reality is the one we inhabit. We must live as if it matters. The theory is a mirror, reflecting our fears and hopes. For some, terrifying, for others, thrilling. Either way, it deepens the mystery and our search for meaning. So where does this grand tour leave us? The simulation theory blends physics, computer science, and philosophy. A fascinating lens, still a possibility without proof. Could we detect the program? We'd need a definitive signature. Perhaps a fundamental pixel of space. Or a hidden message in the cosmic microwave background. Are those distant suns real plasma spheres or rendered points of light? The feeling of awe is the same either way. If simulated, someone wrote magnificent rules. If not, they arose, perhaps more astonishing still. If we value truth, our path is clear. Keep looking, keep questioning, keep exploring, no matter where it leads.
So what do you think? Is our universe truly real, or could we be living inside a simulation far beyond our understanding? Let me know your thoughts in the comments. And don't forget to subscribe for more mind-blowing science videos.